Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU Bhilai. In this tutorial, we discuss about the Huffman's coding with algorithm. So first we understand Huffman codes, why we required a Huffman codes. So basically we required Huffman code by three properties. The first one is that data can be encoded efficiently using a Huffman codes. Why we using a encoding or decoding? When we transferring a message from one place to the another place, that data will be secure, that data will be hacked by another user, and data easily can understand by the hacker also. So for securing purpose, we encoded our data, text data or any voice data or any kind of image data also. We can encoded that data. If any hacker can hack the data, it will not understand the what data will be transmitted by the user to the receiver. So basically for the encoding purpose, we require the Huffman coding. This is our first purpose. Second is, it is a widely used and beneficial technique for compressing data. Suppose when we creating a file, having the file sizes near about in MB, when we transferring a MB data file from one place to the another place, it will take a lot of time, because as we know that if the length of the size of any data will be directly proportional to the speed also. So for that purpose, what we do, we compress the data at the user end, and then we send the data to the receiver end. So when we compressing the data of any size of any file, automatically the length will be reduced, and directly proportional to the speed. If the length is reduced, it will take a less time as compared to the original data what we transferring from the sender to the receiver. So second purpose is to use for the compressing the data file or data. Third one, Huffman's greedy algorithm uses a table of the frequencies of occurrence of each character to build up an optimal way of representing each character as a binary string. We know that when we creating some words, when we making some languages or the words, we require a lot of characters like A, B, C, D or any kind of up to Z. We require a lot of alphabetic words for to creating a any single words, and by the words we can making a language also. So under the greedy, with the help of the greedy algorithm, and under the greedy algorithm, Huffman will support to how many words, how many characters are occurrence in to creating a string or a word in a particular language. So as we know that all the characters are supporting a binary string, either 1, either a 0, how many character will be required and how many binary digits will be required to generating a particular character and particular language. So how many characters are required to generate a particular language. So these three properties are covered in the Huffman code. By the support of this all the 3 points, we enhance our data system, we enhance the security system, we enhance the transferring the data from one place to the another place. For this purpose, we required a Huffman codes techniques. We understand by the example. Suppose we having our 10 to the power 5 characters. It's depend on 1 lakh characters in our data file. Suppose you're making some autobiography by you, or you can write a essay for any person, anything, and you use at that for creating for that one, you're using a 10 to the 5 characters in a data file. Normally storage 8 bits per character, as we know that is completely depend on the ASC second. As we know, the range of the ASC second is 0 to 127, and 8 bits required for the per character. So for the 10 to the 5 bits, we required 8 multiplied by the 10 to the 5. It means 8 lakh bits we required in a file. But we want to compress the file and save it compactly. Suppose only 6 characters appear in the file, like we having a character, suppose A, B, C, D, E and F. By the use of this character, we can generate any strings, and with the help of a string, we can generate any language or grammars also. So A, how many times required A to generating that particular language? The frequencies are given, like A is 45 times, B are 13 times, C are 12 times, D are from 16 times, E are 9 times, and F are 5 times. So total length, it means total quantity of frequency of each character. The quantity is, you can add all the frequency values like 45 plus 13 plus 12 plus 16 plus 9 plus 5. So total count of the frequency is 100. So how can we represent the data in a compact way? That is the main challenging task. So basically there are two approaches. First one, fixed length code. Already user prefix the data length, then execute all the character like that. Each letter represented by an equal number of bits. Already we fixed the size of the bits. With a fixed length code, at least 3 bits per character. We can understand the first point by this example. So example is, now we having A required a 3 bits like 000, B like 001, C 010, D 011, E 100, and F 101. Already we fix. We don't go for the either A will be take a 2 bits, 1 bits, B. We already fixed the length. You have to only 3 bits to store your data. So we required 3 bits. We fix the size of all the character by the 3. That's why all the character are varies by the bit patterns value like a 000, 001, 100 like that, but the bits length are the same. So for a file with 100, suppose we want to send 100 characters. So what will be the required length we required? That is a 3 into 100 bits. That's why the 300 bits are required to transmitting the file from one place to the another place. Because the character with the length of the data or bits is already fixed. That's why we required a 3 into 100 bits. Now we go for the second logics. Second approach is a variable length code. It can be considerably better than a fixed length code. By giving many character, short code words and infrequent character to long code words. We can understand by this example why we required a second approach and what is the purpose of this approach. Here we change. We don't fix the size or length of the data. As per the approach, as per the how many bits we require to reach over the per character from the source station. Suppose our source a root node, and what is the size or how many bits required from root node to the particular character. Suppose in some example, A will be reaching by the only one character, that is called a one length, that is called only 0. That's why we take only 1 bit. Now we take another character is a B. B required a 3 bits to reach from the source node, from the root to the particular the leaf node, that is called a B, and it will require a 3 bits. We take an example 101. It has taken randomly example. We can solve one example and I will tell you how we take up bits in that particular order. So 101 B required the 3 length required, that's why we take a 3 bits. C also required a 3 bits, that's why we take another 100. D also required a 3 from the root node to the D, that is a 3 bits as a 111. E required a 4 bits to reach the destination from the root node, that's why we take some 1101. And the last one is F. F also required 4 bits from this root node, that's why we take another bits format like a 1100. Now how we calculate? In our first approach, we directly take a 3 bits and multiply by the number of character, but here we change. Here what we do? We also take a frequency. So number of bits, how many bits are required? We take one by one. Like A, how many times A will become to make a string? That's the frequency already given that example. So A will be coming 45 times. That's why we take 45 multiplied by 1. Now we take, because A reach from the root node via only a single length, that's why we take only 1 bit. That's why we multiply by the 45 multiplied by 1. Now we take a second B. B required length is, B required a 3 bit and the frequency is given in the question, that is a 13. So 13 multiplied by the 3. Now another example, C, what is the frequency of C? That is a 12. And how many bits is required for C? That is a 3 bits. The length of the 3 bits are the 3. That's why multiply frequency multiply by the length of bit, that is called a 12 multiplied by 3. Now again next one, D, again 3 length bit, and what is the frequency? That is a 16. 16 multiplied by 3. Next is E, the frequency is 9. But what is the length bit? Length bit is 4. That's why we take a 9 multiplied by 4. And the last one is F. The frequency of F is 5. And how many bit length is required? That is a 4 length. That's why we take 5 into 4. So finally we calculate all the data, and what we get the result? We get the result in the form of 2.24 multiplied by 10 to the power 5 bits. So rendered to 24 into thousands. So when we transmitting a data like 105 bits or like that, so thus we required our 2,24,000 bits to represent the file and saving approximately 25%. This is an optimal character code for this file. So when we using this approach, we save the memory, we enhance the speed of transmitting the data, as we know that the length of the data it completely depend on the transmitting the file from one place to the another place. So by this approach we can save approximately 25%. This is a really good challenging for us, that is the optimal character code for this file. We can understand by this example when we discuss that one, so how we calculate that one and how we reach over there. Now for initializing for that one, so first we understand the concept of prefix code. So the prefixes code of the encoding of one character must not be equal to complete encoding of another character. Example, 1100 we take the, and another one is 11001 are not valid codes, because 1100 is a prefix of some other code's word, is called a prefix code. Prefix codes are desirable because they clearly encoding and decoding. Encoding is always simple for any binary character code. We concatenate the code words describing each character of the file. Decoding is also quite comfortable with a prefix code, since no code words is a prefix of any other. The code word that starts with a encoded data is unambiguous. You have to understand, you know the concept of what is the role of ambiguities. If the ambiguities are there, the machine will facing a difficulty which pattern it will select and go through it. So it should be the language and the pattern, it should be a unambiguous, because when the language, when anything is unambiguous, the machine will easily pick the only one pattern to execute for the result and for the goal. So for understanding this one, we required a greedy algorithm for constructing a Huffman code. So Huffman code invented a greedy algorithm. There are lots of greedy algorithms. We already discussed in the ADA part what is a greedy algorithm, why we required a greedy algorithm, and a lot of approaches inside the greedy techniques. So one of the techniques inside the greedy techniques is called a Huffman invented a greedy algorithm that creates an optimal prefix code called a Huffman code. We understand by this example, by this diagram. Suppose we having two variables A or B, A having some frequency, B having some frequency. We add both of them and create some parent node in the form of A plus B, and A plus B are come from the A as well as the B. A should be connected as a left successor of parent node A plus B, and B should be connected as a right successor of parent node A plus B. And also when what we connected at the left subtree we mark as a 0, and what we connected as a right subtree we mark as a 1. I will tell you why we put the value 0 and why do we put the 1. 1 or 0, 0 or 1 like that. From a parent node, how many bits to reach to left subtree A station? That is only we required only 0, that is already 1 bit. Vice versa, when how many length of bit you required from the parent node to the right successor child, that is called a B, you required only a 1 bit. Don't worry about the 0 and what you can change the value at the left subtray. You can put the value 1 also, and here you put the 0 also at the right subtree. That is complete depend on you. That is not a matter, because we focus on the length of the bit. We don't focus on the length of 0 or bit, because we don't converting this 0 1 into a decimal format. We take only the size of that particular way. By this we can understand here in the same phenomena with same pattern. We at all the left child are indicating by the 0 and all the right child are indicating by the 1. So the algorithm builds the tree T analogous to the optimal code in a bottom up manner. Or bottom why? First we connect less frequencies item in the bottom places and the high frequency item at the top places. We take one example. By the example we can understand how we take a bottom to top approach, or we can say bottom up manner. So it starts with a set of C. C is a number of leaves, that is C is a number of character, how many character required to make one paragraph or one string like that one, and perform up to the C minus 1 merging operation to create the final tree. Here we creating a final tree with the help of the character by the help of the frequencies. So in the Huffman algorithm, and denotes the quantity of a set of character. We take one variable Z, indicates the parent node, and that particular parent node comes from the two children like X or Y, and X and Y are the left and the right child respectively of the Z parent node. So for creating this tree, we required one algorithm that is called a Huffman code algorithm. First we understand the algorithm, then we applied this code to generating the Huffman tree. So suppose n equal to, see how many characters we required to generate one paragraph or one essay like that one. So n equal to C, you take up another variable that is a Q. Q is like a parent, the number of total counts it will take from the character. How many frequency required that comes under the Q. To start with the loop, suppose I, you take another variable I equal to 1, you apply a for loop for I equal to 1 to n minus 1, and as you know how many character you required. Suppose you having a 5 character, so the value of starting from 1 and the C means number of characters. So 5 characters you require, it means n minus 1, that is a 4. So starting with the loop, do what you do. In a fifth step, you take the Z variable as a parent node, Z equal to allocated node, it will be arises from the X and Y. You take a X as a left extract mean of Q, it means all the character when you reading all the character inside the n, the which one having a less frequency you pick that one. In a Y again you picking the next less frequency out of amongst of all the character. So another take to another pick one, and when you picking two minimum frequency character, you add both of them and insert the result into a Z by the function f of Z equal to f of x plus f of y. So inserting Q comma Z, that's the value of Z inside the Q, that's a become a parent node, and return extract minimum Q. And this process is continuously going on up to the I equal to n minus 1. First time the I equal to 1, then I equal to 2, up to n minus 1, it is a 5 minus 1, that is a 4. You can count the values and put all the character one by one, in the form of the frequency. You can connect all the character one by one and generate a tree. This is just a pseudo code of the Huffman code, and we applied this pseudo code in the example how we generating or how we creating a particular Huffman tree. We can understand by this example. So, find the optimal Huffman code for the following set of frequency. Here we take 5 variables, 5 characters, like characters are A, B, C, D and E, and the frequencies are of A are 50 times, B are 25 times, C are from 15 times, D are 40 times and E are 75 times. So, this all are the character, and their character will be using to generating some string are the this frequencies times. So, we take this example, and how we generate it I will show you. Here we are taking an example. Here we are having a variables characters like A, B, C, D. All we insert one parameter inside these C. So, we take an example f of C equal to like that 50, 25, 15, 40, 75. So, the total number of n equal to 5. How many characters you required? A, B, C, D. That is why we take n equal to 5, and Q you passing the value of C inside the Q. So, in I equal to, it means you put all the values with the help of frequency like A equal to 50, B equal to like that and so on. You like the E equal to 75. So, starting with I equal to 1, 2, n minus 1. Here we are having a n equal to 5, that is to put the value of 5 into that formula. Then the 5 minus 1, that is called a 4. That is why we are starting from the I equal to 1. Z is the allocated node, X is the extract minimum from the amongst of the item of the frequency of the character, and Y is another extracting minimum Q from the character frequencies based on the frequency. So, here you pick two minimum values like 15 and 25, and this 15 and 25, the first one is a B item, the B character, and second one is a C character. You pick both value B and C. First you insert these values inside the X and Y, and let's you add them into a f of z by the help of f of x plus f of y. So, you adding 15 plus 25. So, first you write first minimum value, that is called a 15. It means you write a first write down the C, then you write the B. Rest of the item are as it is, no changes, they will be shifted to the right hand side. First you pick the first minimum value, that is called a 15, that is come under the C, and the second minimum item is a B, that is a frequency is 25. So, first you select both of them, add both of them, and result should be put into the f of z. So, you when you adding 25 plus 15, that is a 40, and that is a f, that value will become under the f of z. So, what is the result after we connecting that one? So, tree will be generating, as you see, the parent node is the value is 40, that's come under the z. That 40 is coming from the two variables, two character. First one is a C, second one is a B. The frequency of C is 15 and the frequency of B is 25. C is a meanmost child amongst of all the character. That's why it should be connected as a left subtree of the parent node, and B is a next to the minimum value of the amongst the character. That's why it should connected, and the B counts of B is greater than the counts of C. That's why it should connected as a right subtree of the parent node. That's why we are generating a tree. Here 40, or we can say Z will become a parent node, and C and B both are the children, C as a left successor and B as a right successor respectively, with the having a frequencies value 15 and 25. Now, after we adding this one, now we having only a 4 items. This first is a new item, that is called a parent node Z40, and rest of the item A, D and D are as it is. Now, again we go for the same value and we find out the minimum two values from the C. Now loop will be begin, that I is increasing, we are insiding the loop. Now I will be increasing, that is I equal to 2, and after the I equal to 2, now we select two minimum values amongst of all the remaining all the data. Now we having that's the one new value, that is called a x having a value 14, and the rest of the value which is not still not coming on the operation, that is D, A and E, D having a frequency values 40, A is a frequency value 50, E is a 75. That's why we fix the variables in as per the frequency order or ascending orders. That's why first we pick a D character, because the D character frequency is less as compared to the rest of the characters value. So we pick the D value. Already we having a X value what we generating from the with the help of B and C, that is also a 40. So 40, X is 40, D is 40, A is 50, E is 75. So again we pick a two minimum values in the form of X and Y. So X is 40 and the Y is again come from the D, that is also a 40. So again left of Z, left or right of Z is X and Y. Again we connected f of Z 40 plus 40, and the total equation is equals to 80 with the help of X and D. So again we generating a tree in this format by the connecting the tree. So 80 will become our root node of this tree, and this 80 are come from the two children's. First is X and second is D. If you see, D should be connected as our right successor of parent node 80, and the 40, this is a value variable is X. It should be connected as a left successor of 80, because that particular 40 left hand side 40 will be coming from the C and B. That's why the frequency of the that particular 40 is 15 and 20. Frequency of C is 50 and frequency of B is 25. That's why the merging, when we merging are two same parameters value, so it should be first we connected a left subtree what will be taking as a previous one, then we take a next one. That's why we connected 40 left 40 as in the form of X and the right successor in the form of D. So the left 40 it coming from the C and B, that's why it taking the left hand side value. So the total for the C and B, 80 is a grandparent, and in another word for respect of 80, C and B are the grandchildren of this tree. The total operation, the generating tree is this one. 80 will become a root node, 40 inside the X, 40 inside the D, another children's, and C or B also will be showing because that 40 is coming from the C and B. Now again similarly we apply a same process and we get the same thing, because right now we containing only C, B and D. Remaining two frequencies values are A and D still left. Again we find out, we take all the values and we find out the minimum values amongst of them. So we go for the find out the minimum value from the C characters values frequency like that. Now again so we check here the new value that is called that is a previous tree what we derived from the variables, that is a 80. Another, that is a, suppose you take another variable like t equal to 80, you take the previous values like A equal to 50, E equal to 75. You now find out the first minimum value. The first minimum value amongst of all the character are the A is 50 and E is 75. So you left the derivation tree right now. You pick only the two minimum values, and two minimum values are A and D, and you merge both of them, and after the merging it will the parent node will become a 125, and 125 are coming from the A and E, and A having a frequency is 50 and E having a frequency is 75. You connected both of them. Now after connecting both of them, now you having a two separated trees. One tree is having a parent node is 80, another tree having a parent node is 125. Now all the rest of the children are connected as well as, now you having a two trees, one is holding by the 80 and another is holding by the 125. Now no any rest of the item is available. Now you merge this to both derivation tree with the combination and generate a one parent node of both of the tree. And what is a tree right now? So this is a final tree after merging all the data items. So 205 will become our root node of this tree after merging the two separated tree, and the separated tree minimum frequencies are one is 80 and another one is a 125. We should to connected 80 as a left subtree because the number of frequencies value 80 is less than 125. That's why we connected 80 as a left subtree and 125 as a right subtree. So 205 will become our root node of this tree, and we connected a tree as it is pattern like what we connected in the previous previous pages, like that 80 coming from the 40 and another 40D, and that particular left 40 is come from the C and B, and the 125 which is a right subtree of two parent node 205, and 125 is coming from the two children, that is called A and D. So after merging all of them, this is a final result, final tree of this Huffman code. So this is a 205 is a complete total of this tree. Now, why we go for this one? So first we will draw the, as I told you, as a left child should be connected as a 0 value, and a right child should be connected as a 1 value. In a all left child, you put the value as a 0, and all right child you put the values 1. Like first you connected starting from the root node to the left child we indicating a 0, and the right child we indicating a 1. Now 80 from the 200 are coming from 0, and the 125 coming from the root node is a 1. Now all the left child are the indicating by the 0, and all the right child are indicating by the 1. You can vice versa also, you can put the value 1 at the left hand side and 0 you can put the right subtree also. That's completely depend on you. That is not a matter, because we can't convert in this value into a decimal format. Already we indicate this 0 or 1 to understand how many bits to required from a parent node to the particular leaf node. In this particular tree, we're talking about some character like when we're taking a. So how many bits you require to reach the A? So A is available as a left child of 125, and as compared to the parent node, A will coming in a right grandchild of a to parent node to root node 205. So how many bits you require to reach the A? So first you travel 205 the root node to the 125, that is a 1 bit. Then 125 to A, that is another bit, that is a 0. So you will require a 1 and 0. Another one, when we are reaching a E, we are requiring a 2 bits, one from the root node 205 to 125 1, and 125 to E, that is another bit 1 1. So in a both character A and D required a 2 bits, but you have to all the values are separated to each other. They are not looking as it is same. That's why we indicating a 0 and 1, left child as a 0 and right child as a 1. In both way we require a 2 bits, but the pattern are different, because in a you required a 1 0, in a B we requiring a 1 1. That's why patterns are different, but both both characters require the same length of the bit. Same as it is when talking about the C, you require a 3 bits. 3 bits are 0, 0 and 0. First one 0, 200 for parent root node to 80, 80 to 40 and 40 to C, that is called a 30. You require 3 bits you required, and all 3 bits are the zeros. Same in the B, you required a 0, 0 and 1. In a D, you required a same 0 and 1. It means when you're talking about the C and B, both having a less frequency at rest as compared to the rest of all the character. That's why these two variables are having a less frequency. We connected as a bottom layer, or we can say the bottom to the top approach. As I told you in the previous slide, what is the bottom to top approach? Which character having a less frequency should be connected as a leaf, or because the level of that particular tree of this less frequency item should be connected in the bottom way, and by the bottom way we can connect it all the rest of the item by the base, which is based on his frequency, because the highest frequency character should be take a maximum time. That's why we connected this particular character as close as to the root node, because when we performing any operation it required a less time, because here can you see E having a maximum length, that is called as 75. So only 2 characters you required, 2 length you required, 2 bits length to reach the E. But when the frequency is lesser as compared to the rest of the character like C and B, it requires a 3 bit character. That's why There's a main logic of this principle of this Huffman code. By the use of this one, automatically the calculation will be reduced. So when you're calculating all the things A, B, C, D, E, so you can calculate with the help of the addition operation like A plus B plus C plus D plus E plus F. And for it is a length value of A is a 2-bit, then B is a 3-bit, C 3, D 2. And when you're calculating all the values, what is the final value is 12. Here we don't require a F, only we require a E. A plus B plus C plus D plus E. All the values will be added. The total length is a 12. When we using a ASC second, here we fix the length. We fix all the character by the 3 bits value. And when you're taking all the 3 bits value, all the 5 character, you require a 15 bits. And by this operation, the second approach, you require only 12 bits. It means automatically the size of the data will be reduced. If the size of the data will be reduced, when we transferring the data will be compresses also. Size will be reduced. It means the data will be compresses. And when we compress the data, automatically transmitting speed as compared to the previous approach, it should be a high. That's why we can say our system will be as enhanced by the logic of Huffman coding. Though by today's tutorial, I hope you understand the concept of Huffman coding, why we required, what is the role of encoding, how we do encoding by the greedy technique Huffman code, and how we compress the data, how we send the data. So by this, you understand the concept of Huffman coding. So for this tutorial, thank you.